actually, that's plus 3. So if I graph, I can graph this by hand. This one's a circle, 0, 0 is the center, and we go around by 3's, so this will be by 3's. And then this one is x squared, y is equal to negative x squared plus 3. So that means that's at positive 3, and it's going down. And it's going down like this. That's what the graph looks like. Okay, so knowing that, I see there's 0, 3, and negative 2, this must be negative 2, and that's about negative 2.2, and this is, let's see, negative 2, square root, this is square root of 5, so it's about 2.2, and then this is going to be 2. I can't show it exactly right. So these 2 points match those 2 points. And you don't need to do that graph, but you have to get those points. Okay. Now, one more that's a really big one. Please write this one out. 2x squared minus 8y squared plus 48y equals 90. Negative 48y plus 30 equals negative 8y squared minus 2x squared minus 8x. For some of you, now I can challenge you. This one should be a little more challenging for those of you who feel like, okay, I got this one's easy. This one might take a little bit of work. So, first thing you need to do is put these in normal form so you can match things up and look and see what you have. Because this second one here, you have squares here, you have x's, basically get them both equal to 0 is the best thing. Get them both equal to 0. So I'm going to rewrite this one, 2x squared minus 8y squared plus 48y minus 90 is equal to 0. And on the other one, I need the x squared over here, so I'm going to add 2x squared to both sides. And then I'm going to add 8y squared to both sides. And then, let's see, that takes care of that one, that takes care of that one. Then I'm going to add 8x. And I already have a minus 48y. And I have a plus 30. Now, they're both in the same form. Now we can analyze it. It's like a lot of things in math, is you want to organize the data or the equation first before you start doing something with it. Life's a lot easier if you put it in a form that you can work with. So, look at it and notice that you have these two are exactly the same. These two are not the same number but opposite sign. So that gives you a couple of ways you can work with this. So what I'm going to do here is I'm going to give you about a minute or so to start it yourself first, to see what you would do and do that first couple of steps, and then I will go through it. Okay, so think about what you can do. This is more complicated than the others, but the concept is exactly the same as the others. Same concept. This should have been your first step. I added them because these two are going to cancel out and these two are going to cancel out. Now, if you chose to subtract it, let's analyze something. So even if you're still going, stop for a moment to look at this so you can see what's going on here. This you're going to get, I'm going to work with that in a moment. But let's say I had subtracted it instead. If I had subtracted it, I would have gotten rid of the x squares. Cool, that looks cool. Except I have a problem here. I get negative 16y squared, and here, because that one becomes positive, 96y, and I get a negative 120, but I have this 8x, this negative 8x. I did not eliminate the x's. The goal is to eliminate one of the variables, and if you subtract, if you get misled by this, you get stuck. So the thought here is eliminate a variable completely. These questions are always set up so you can do it one way or the other. You just have to figure out which one. So now seeing that, so you see not this one. For this problem, it's not subtracting. It might be for another problem, but not for this one. So now you're back here. Don't try factoring this yet. Okay. So you should have gotten this once you added it. Okay. Your next step, this is where you want to think about your numbers. You see all these numbers, they're all divisible by 4. Divide both sides by 4. Life is going to be so much easier. Okay. There's a key thing on here because what I've seen, and you've seen problems, if you haven't seen them in the book already, you'll see it on the test like this, where you get numbers in there, where if you don't immediately reduce, simplify it, life becomes very hard. You can actually still do this. You can factor it without reducing them all. But right now, divide both sides by 4. So it gives me an x squared plus 2x minus 15 is equal to 0. And life's going to be so much easier. That's why I make the big difference. Factor, and it looks like to make 15, it's a 5 and a 3. Now you see again why I emphasized factoring earlier in the year, and wanted to make sure you know them. So now x is equal to negative 5 and positive 3. So now what I have to do is I'm going to have to do x is equal to negative 5 and x is equal to positive 3. I'm going to have to figure out what the y's are for them. And in my case, I ran out of some room on the paper because I wrote it so big, so I'm going to just take this and move. So you can be working on that, but make sure if you didn't do these steps this way, that you remind yourself, think to yourself about what you would do if you were in this situation again, about how you have to remember or remind yourself to do these kinds of things. Okay? To simplify it, to get rid of a variable. And then I'm going to pick this up as x equals negative 5, x equals 3. So I'm going to choose one of the two equations. Okay. So for these, I'm going to look back here and choose one of these two equations. This one's definitely the easier equation, a lot less in it. So I'm going to do 2, negative 5 for the x, 2x squared minus 8y squared plus 48y is equal to 90. And over here, 2, 3 squared minus 8y squared plus 48y is equal to 90. Okay? So that's 25 times 2, we get a 50 here. So what we get is negative 8y squared plus 48y. And here I get, well, I guess what I should do is subtract that on both sides, but then I'm going to bring it back over. That negative y squared, get rid of the negative. So first I'll bring the 50 over. So subtracting 50 both sides. Now I'm going to divide both sides by negative 1. I'm going to get rid of that pesky negative there. And it's perfectly legal. Take advantage of it. Take advantage of that fact that you can play with negatives and positives. Good, I got my negatives and positives right. What should I do now?
Excuse me, mine wrong 50, it has 40 and not.
Oh, it is. I even wrote 40 on my notes. I'm so busy thinking of the 50 here that I kept it. Okay, but what should I do now?
Divide the whole thing by 8 and then after.
Exactly right. Thank you. Life is going to be so much easier dividing everything by the 8. So if I divide this side by 8 and that side by 8, well, 0 over h is 0. So here I get y squared minus 6y plus 5. Make sure I really got them right in the nose. That's so much easier to work with. That's why you make your life easy if you do some of these little things. Okay? So we get y plus 5, minus 5, and minus 1. So you have two y's here. Y is equal to 5 and 1, but that's when x is negative 5. So we have negative 5 and 5, and we have negative 5 and 1. See how you can determine that there's two answers. So I used one x, but when I got down here, I ended up with two possible y's, so that x goes with both of those. So I get to use the negative 5 twice with one y and then with the other one. You have to do the same thing over here. So let me come up here and do the same thing. That's 9 times 2 is 18. Okay, and then minus the 8y squared plus 48y, so we get 90. So now, if I subtract the 18, I get a 72, I believe it's over here. Okay, I have that in my notes too. So I'll get 72 there. Negative 8y squared plus 48y. And I'm going to bring the 72 back to this side. So I'm going to make sure if I subtract 18 and subtract 18, that gives me a 72, and then I subtract it from both sides to get everything over here. I'm going to divide everything by a negative 1. I could just divide everything by the negative 8 right now and do it all at one time. Okay? So that gives me y squared plus the 6y. Nope, it's a negative. Negative 6y. This one's going to be plus, and 8 goes into 72 9 times. So I get a negative 6y like over here, but I get a 9. So now this one factors a little differently. You factor it. What's it come to? Everyone already get it?
Y minus 3 times y minus 3.
Okay. This one's a perfect square one. So it's the same one, which means it's really just, one number. We have y is equal to a positive 3. It's a double root if we were doing it that way. You'll hear that term sometimes. But it means I only have one answer to go with this one. 3 and 3. So I have 3 answers for this one. This one looked like, when you go down, it's the same kind of setup. You thought, okay, I'm going to get 2 answers for this one. Doesn't happen because it's perfect square. No problem. So you roll with the problem. You figure out what the problem's doing and show you and roll with that. Okay. So this one, I took 2 pages for this one. We'll try it. Where first it was figuring out how to eliminate one and then simplifying that and factoring it to get one of the variables. And then using both answers for that variable to get the other variable that matches or goes with that number. Any questions about doing this? So just use your awareness of numbers and the variables, and notice that in all the ones we did, we always got to equal 0 for these. That's always a key idea. And always try to reduce down as simple as possible to a quadratic that you can work with, an easy quadratic. So always look for a common number that you can divide on both sides to take out. If this had been a 59, we'd have been stuck. Quadratic formula and have some decimal or square root answer, which we could live with, but it's really nice if it's not that way, and you'll often get nice numbers if you just divide when you're able to, so you can get something much easier to work with. So those examples I just went through is 4 or 5 of them of ways of doing the algebraic method to figure out where those points are with these means. Now we're going to look into the inequalities, the graphing one. And to do that, I think we have enough time to get until 35. We have enough time to do a couple of these again. So I'm going to ask everybody to take 2 of these papers. I already have the graph part set up, so I might as well just use them. Okay, so 2 per person, please. Here, pass on and I'll take the extras. And I'll take you through the extras, and I'm not sure there were enough. Okay, so. 2 for you, 2 for you, and grab a couple. Thank you. This was something, right? Oh, I'll use that one. So on the top one, this is still part of 8.7, still in section 8.7, and I'm going to give you 2 of these. We're going to do x squared plus y squared less than 4, and y is greater than negative x squared. So here, we're going to graph these. Now, this one gives me 0, 0 is the center, and clearly it's a circle because they're both the same. So I have a radius of 2, square root of 4, 2. Okay, so I have a radius of 2. So that means I'm going to go to here, 0, 0, and I'm going to go up 2, and out 2, and out 2, and 2, and I'm going to put dashed lines because it's not an equal, it's just a less than. And now I need to determine if I'm going to shade the inside part or the outside part. So pick a number, and 0, 0 is stuck right in the middle of the inside. Nothing wrong with using the center because that's clearly inside it. So if I put 0 plus 0, I get 0 less than 4. 0 less than 4 is a true statement, so I'm going to lightly shade that. And now, let's determine where this is. Okay. Well, y equals x squared. Y equals x squared is a parabola going like that, so it'd be going up like this. Y equals negative x squared is going down. So that means I'm going like this. So there's the parabola of negative x squared. Okay. But because it's in, and notice I made it equal because it's just easier to make it equal to figure out where it goes first, and then now I can shade once I figure out where to shade. So I can't use 0, 0 because that's actually on the line. That'll make it false because it's not equal 1. So I need to pick something else. I'm going to pick this one that's on the inside of it here. Okay, so I'm going to say this one is 0 and negative 5. And so if I say that the y is negative 5, greater than negative 0 squared, negative 5 greater than 0, that's false. That's not true. Put a line through that to show that's not true. So I do not shade the inside of it, I shade the outside of it. And that means the place where they both meet. There we go. And that's the solution, and that's what I need to see. Inequalities, there's a couple of ways for me to check that you know how to do them, but this is the best one in my opinion because you actually have to do it. The other way that you'll see on standardized test type things is they'll give you like points. Okay, so a point from say here and here and here and here, and you have to determine which of the points is actually in the correct area. Well, that's just substitution. You just take the points and plug them into both and see if they're right. So that doesn't take any actual understanding in order to, you know, I can't tell you really understand how to do this. So I'll make you actually graph them. I'm probably going to give you 2 of these on the test. So let's do a couple more. Okay, so this one down here, let me do, take some notes off of this. I'm going to give you another parabola, y equals, oh no, not equals, y is greater than, sorry, I messed that up, y greater than x squared minus x minus 6. And I'm going to give you a line, a linear inequality. X plus y is less than or equal to negative 3. Okay, so you need to graph this. And there's a couple of ways to graph it. This one's easy to graph. That's just a linear equation. I'd recommend to go ahead and graph it. X plus y, think of it as x plus y equals -3. Think of this one as y equals x squared minus x minus 6, so we can graph it with that. You can use the graphing calculator for these. You cannot easily do it with circles, ellipses, and hyperbolas. If you want to try, you can, but you have to do it by moving them around to get y equals, which means you take the square root plus the square root of one whole side and minus the square root of one whole side. So it'll work for you, but it's a lot of work. If somebody's really interested in doing that, come on into a math help time sometime, and I'll show you how to do that, how to graph a circle, ellipse, or hyperbola on the TI-84s. Okay, but here, well, this one is y equals -x minus 3. And it looks to me like I have -3 for my y-intercept. This should be easy. At this point, you should know. You know how to use the b, and you know how to use the slope, -1 in this case. Let's see, that's a solid line. Where do I shade? So let's use 0, 0. 0 plus 0 is 0, less than or equal to -3. 0 is not less than -3, not in this math class. So that means we're shading over here. I don't know where exactly it'll end up being, but okay. Now, let's talk about graphing the parabola, because you have a couple of ways that you can do it. Okay. Now, you should remember, I'm sure that you did this in Integrated 2, where you get, for the vertex, you need the h and the k, so you need an x and a y value for the vertex. You can find the vertex of one of these by using this formula where x is -b/2a. If you've forgotten that, remember it, because it's really helpful to get you your starting point for a parabola. So the b is -1. Oops, I have to do, I'll write down here. X is equal to -1 is the b. And the a is 1, so it's 2. So that means it's 1/2. So at 1/2, okay, now we have to figure out if that's the x value, what's the y? Well, if you put that x back into here, you can get the y. Y is equal to 1/2 squared minus 1/2 minus 6. So that's -6.5 plus 1/4. Y is equal to -6.25 is what it comes to. So that means I have a point that's 1/2 and -6.25. A half is here, -6 is here, and -6.25 is about here. So here's the vertex. And if I plotted a couple of points, I would be able to graph it. I'll tell you right now, it's going to go to about here and here, and then up to here, here. Parabola. So see how, make sure everyone gets that in. So what I did is I found where the vertex was by using that little formula. You've seen it before, but probably haven't used it as much since, so I'm going to remind you about it. It makes it much easier to figure out where a parabola starts. And then I found the x from it and found the y from it, and that gives me my starting point. And it's a normal shaped parabola, which means I'm going over 1 and up 1 first, and then 1 and 3. You can graph a couple. You can always graph a couple of points. Do an x-y table and graph a couple of points on both sides, and you can get, really easily get where it's graphing. Now we have to shade it, because we're either going to shade it on the inside of it, which means this would be the answer, or we're going to shade it on the outside of it, which means all around here would be the solution. So I need some space. I'll draw a little line here. 0, 0 is a good one for this also. So I can put 0 greater than 0 minus 0 minus 6, 0 greater than -6. That's true. This one's true, which means we shade the entire part here, but that means only this part is for both. There's your answer. Only that part is where both the parabola and the linear equation or linear inequality are both shaded at the same time. So any of the points in here will make both of these true. That's what you're looking for, where both of them are true at the same time. Now I gave you 2 pieces of paper because we're going to do another one on the other side. Okay, so let's set up one over here. Okay. So I have enough time to do one more of these and go over something. Let's do this. X plus 1 squared plus y minus 2 squared less than 4. And I'm going to do a little line here and put the second one down here so we can work with it that way. Y minus 3 squared over 16 plus x plus 2 squared over 4 is less than or equal to 1. So what we have here is a circle. We have a radius. We have a starting point. In fact, let's find the center. -1 and +2, and the radius is equal to 2. Take the square root of it. So we have enough information here to put that. Let's go ahead and do that. -1 and +2 looks like puts me up here. And I have a radius of 2. And this is a dashed line. I'm going through this a little fast in a way, but I think each of these things are things you already know. You know how to get the center out of it. You know how to get the radius. You know how to graph them. You recognize that this is a dashed line, not a solid line. So we don't really need to re-explain them, but I'll mention them as I go through them. And again, if you don't recognize why I'm doing something, ask me or come now or come to a math help time so I can go over any details that you're not sure about from some of these and explain it in more detail. So now figure out where to shade. 0, 0 is pretty clearly on the inside of it. However, I don't have to use 0, 0. One of the nice things about ellipses and about these other ones, ellipses, circles, hyperbolas, is I can use the center point. Help me out. Yes?
This is a circle, right?
Yes, this one's a circle.
So on the bottom, you went 3 dots down.
Ooh, I did.
So 0, 0 is on the outside of it.
It is on the outside. But now you see it's so close there, I'm not even going to bother using it because clearly I'm going to make a mistake if I do that. But I can use the center point because that one I don't have any question, and if I'm drawing it wrong, it's not going to stop me from getting that one right. So thank you for letting me correct that. Now I'm going to use the center point and put it in here. -1 plus 1 is 0, so that's 0 squared. 2 minus 2 is 0, so I get 0 less than 4. See why using the center point makes this really easy to get zeros. So you don't have to do it. You can use some point out here if you feel like. It's just, this is a nice, easy way, and I have other things to do with my time than do a harder, longer one, so use that and get zeros. So that's true. Therefore, this inside part is shaded for the circle. This one's positive, so this is clearly an ellipse. Okay? This is the ellipse format because it's the these with the 1 and positive, and so let's play with it. We have the center. Aha! Careful here. I was about to put 3 and -2, and then I realized that's a y and that's next. I caught myself. I want you to catch yourself the same way. It wasn't even on purpose this time, but it does happen sometimes where you want to think, oh, that's 3 and -2 because that one's first. Nope. That's with the y, and this is with the x. So it's -2 and +3 is the center of the ellipse. Okay? So -2 and +3, so here's the center of the ellipse up there. Okay, so slightly different, pretty close to where the circle is. And now I figure out that A is equal to 4, B is equal to 2, okay, square roots of them. But because the Y one is, because the larger A is underneath the Y, we're going up and down. So I'm going to go up the 4, I'm going to count them more carefully this time, and down the 4 points, 1, 2, 3, 4, and over 2, and over 2, and a solid line. There's my ellipse. Okay. I have to admit, when I did this for practice, I drew it a lot nicer. That's what it should look like. That would be a lot nicer. But you get the idea here. Let's continue. Let me continue to work with this one. So we stick with this one. And now we're going to shade the inside or the outside. So I'm going to take that center point, -2, -3, and put -2 in here to make 0, 3 in here to make 0, 0 and 0, and I get 0 less than or equal to 1. And that's true also. So the inside is shaded, but that means this part is where they're both shaded. So there's the solution. So again, if I use the center point, using the center. So I'm testing it using the center. I don't have to, I can use another one, but that makes it easy. So both of them are shaded on the inside. If this had been a greater than or equal, then I would have been shading the outside, which means only this little part here would have been true for both. So that's why I can make a different problem by just switching the sign and then see. So you don't know what you'll get, just be really careful. Use the center for those.